Welcome to Chapter 5, Lesson 1 in the Pearson Geometry video series. Today's lesson is about perpendicular and angle bisectors and the theorems we can use to build proofs and solve problems. Let's start with the term equidistant. Equidistant means the same distance from two or more points. Same distance from two or more points. Let's construct some equidistant points from A and B. A and B are the endpoints of segment AB. So if I take my compass and I open it a little more than halfway, then I can put the point on point B and draw an arc. And then I'm going to do the same thing, put the point on point A and draw an arc. And I have two intersection points. And these two intersection points are going to be the same distance from point A and point B. So, if I go ahead and connect those with a straight edge, and then I measure them, and let's go ahead and connect the second set too. Then I know that these two are the same, and these two are the same. Also, if you remember constructions from way back when, if we connect these 2 points, we have created a perpendicular bisector. And a perpendicular bisector means that this segment and this segment are also congruent. So we have all kinds of congruent pieces and parts using that construction. Now, for the perpendicular bisector theorem, Theorem 5.1, what do we already know about perpendicular bisectors? Well, first of all, we know that a perpendicular bisector creates right angles. And we know that the perpendicular bisector cuts the segment in half, so two congruent parts. So this box and these hash marks show a perpendicular bisector. Okay, so according to Theorem 5.1, a point that's on the perpendicular bisector of a segment, and that would be point P in this case, is equidistant from the endpoints of the segment, just like we had over here in our constructions. So that means that these two lines are congruent. Okay, now let's take a look at Theorem 5.2. Theorem 5.2 is the converse. The first theorem, 5.1, says a point on the perpendicular bisector is equidistant from the endpoints. Theorem 5.2 kind of switches that around. It says if the points are equidistant, and we'll go ahead and write that on here, if the points are equidistant, then line L is a perpendicular bisector. And so we can go ahead and show that, adding the box and the two hash marks to show that those are bisected or congruent halves. So this one says, given a perpendicular bisector, these two lines are going to be congruent because point P is equidistant from the endpoints. This one says if point P is equidistant from the endpoints, then line L is going to be a perpendicular bisector. So these are right angles and these are congruent. Now let's look at a proof of this theorem. We have one correction. Line 7, instead of angle PXY, that should be angle PQX. So you're going to want to change that in order for this to make sense. Okay, we have a ton of information here. First of all, we always start with the givens. Okay, so what is our given? It's both written and it's shown. px is congruent to py. Okay, so px, or in this case, is equal to py. And that's going to be our given. And we have one of those over here. So let's go ahead and cross that out because we have an answer bank over here on the right, and each of these is going to be used exactly one time. Okay, so what do we notice from that? From px and py, I have two sides of a triangle that are congruent, which means that I can classify triangle pxy as an isosceles triangle. So do we have something like that? We do, right here. So triangle pxy is an isosceles triangle. Okay, now how do we know that's a triangle? We know that's a triangle because it has these two hash marks saying the sides are congruent. Okay, and we know that makes it an isosceles triangle because of the definition of an isosceles triangle. Let's see, do we have that here? We do, in fact, have that. So definition of isosceles triangle. Okay. So what else do we know about an isosceles triangle? Well, we know from the isosceles triangle theorem that angle x is congruent to angle y. So do we have something over here like that? So we have pyx and pxy. That would be those two right there. So angle pyx is congruent to angle pxy. And that's going to be the isosceles triangle theorem. Let's see, we can go ahead and cross that out, and isosceles triangle theorem. Okay, side 4, or statement 4 says let Q be the midpoint of segment XY. And we know that every segment has a midpoint. So that's just going to be the reason there. And that one's kind of iffy. That's kind of hard to come up with on your own. So given that Q is a midpoint, what else do we know? All right. And then we're going to prove that two triangles are congruent. Which two triangles are we going to say are congruent? So go ahead and see if, as you mark your diagram, make sure you're marking your diagram as you go, you can finish this proof. All right, now time to solve some problems. Let's take a look at problem number 1. Okay, so what do we know about this triangle? We know that this line AC forms right angles and that BC and CD are congruent. That tells us that this is an angle bisector. If this is an angle bisector, then these two distances, AB and AD, are congruent. So we can set this up. 6x minus 10 is equal to 3x plus 2. From here it's algebra, so go ahead and solve that. Okay, over here, problem number 2. This one's a puzzle. It gives you all the information that you need in order to find out what OL is. So see what you can find out, see what you can deduce using your deductive reasoning skills to figure out excuse me, the distance of OL. All right, now we have 2 more theorems. And these 2 theorems are very similar to the 2 theorems on the other side. 5.3 is the angle bisector theorem. And if you remember, an angle bisector is a ray that divides an angle into 2 congruent parts, making these 2 congruent angles. So this theorem says a point on the angle bisector is equidistant from the 2 sides of the angle. And then over here we have the converse. And the converse says if the 2 points are equidistant from the 2 sides of an angle, then it's an angle bisector. Okay, something else that you need to notice is that right here we have right triangles. And these right triangles are showing that this is the shortest distance from the point to the side. So if these are not right angles. If these are not perpendicular lines, then you don't have the shortest distance, and you must have the shortest distance in order to determine whether or not those are equidistant. Okay, so what do these theorems mean? These theorems mean, first of all, if AD is an angle bisector, then BD is going to be congruent to CD. They're going to be, C and B are equidistant from point D. Okay, over here, if BD and CD are congruent and they're perpendicular, then AD is an angle bisector. So here we can prove congruent lengths. Here we can prove an angle bisector. So let's take a look at the last problem. If JL equals 14, so that's all of this part right here, and ML equals 7, and KL equals 10, what is JK? And I think you'll be able to figure that out. Now, make a note of any questions and ask them in class. See you later.